In this next video, we're going to talk about compound inequalities. Now, these type of inequalities are basically two inequalities in one. So sometimes, you might, we've been dealing with x is less than 5, for example. Now what you're going to deal with is you're going to deal with one inequality and another one. So for example, x is, I don't know, greater than -4. Okay, so you might deal with something that looks like this. And what you will have is an and in the middle. Okay, so here's my example. My example will be x is less than 5 and x is greater than -4. Okay, so these are what we're going to call and or statements. So you have two different options. So you have one that has an and, or two that has an or. So we'll first do the ands. So what the ands mean is that you want to look everything that is together. So here is together or in common. So everything that's together and in common, what do both of these things have in common? That will be the solution. So how would you solve this type of inequality? X is less than 5 and x is greater than -4. So the first thing that you will do, you would start off with x is less than 5. So let's start off with graphing it. So here is 5. 5 is somewhere here. 5 is not included, okay? And we want everything that's less than 5. So everything that's less than 5 is all of this. Here's everything that's less than 5. Okay, now we want the other one now. So x is greater than -4. So I'm going to graph this. -4 is a little bit less than 5. -4 also is not included and it's everything that's greater than. So all of this stuff. Okay, so what we want is an and statement. So here, this and means what do they both have in common? So let's look at everything where they both have shaded region. So this one has shaded region here, but this one doesn't, so that's not it. Here it has shaded region, and this one also has shaded region. So it's everything from right here all the way to here, because then this part doesn't have anything. So everything where I put the dotted lines is where you have similarities. Okay, so what is this going to be? Well, this part is everything from -4 not included all the way to 5 not included. So everything that's in between these two numbers will be a solution. So the solution to this answer, to this question, will be from -4 to 5. That is my answer. Okay, that's all there is to it. Okay, so now let's do another problem. Okay, now that you kind of get the gist of it. So my next problem is going to be, so solve and write in interval notation. Okay, so my problem is going to be, this is going to be part A, x is less than 3 and x is greater than or equal to 1. So you can try this problem out first if you want. You can pause the video, try it out, or you can just watch me do it. So first we're going to look at x is less than 3. Okay, so where is everything that's less than 3? So 3 is going to be around here. 3 is open circle because it's not included, and we want everything that's less than 3. So everything that's less than 3 is all of this. This is everything that's less than 3. X is greater than or equal to 1. Well, this 1 is less than 3. Since it's equal to, it's going to be included, and it's everything that's greater than. Okay, it's going to be all of this. Okay, so now what we're looking for is where do they both have things that are in common. So the first number that they both have in common is 1. And then the next number is 3, but 3 here is not included. So the area that they both have in common is from 1, where 1 is included, all the way to 3, where this is not included. Okay, so my answer is going to be bracket 1, because 1 is included, all the way to 3 not included. Okay, that's going to be my answer. Okay, so now let's look at another type of problem. let's say we had x is less than 10 and x is greater than 20. Okay, so x is less than 10. It's going to look something like this. Here is 10. 10 is not included, so it's everything that's less than, okay, because we want x is less than 10. X is greater than 20 is going to be, well, 20 is over here. It's not included, and it's everything that's on the other side because it's everything that's greater than. So do these have anything in common? The answer is no. So you can either write no solution because they have nothing in common, or you can write the empty set. Okay, so no solution will be just perfectly fine. Okay, now let's do other types of problems where you actually have to work a little harder. Okay, so part C. Let's say we have one with a fraction. So for example, 3/4 x minus 5 is greater than or equal to minus 2, and negative 3 x plus 1 is greater than or equal to 6. Okay, if you feel brave about this, you can go ahead and do it. If not, you can watch me do it. Okay, so the first thing that we're going to do is that if you notice all the other problems, they were already solved for us. This one is not solved, so we need to go ahead and do it. So the first thing that we're going to do, let's solve the first problem. I'm going to add the 5 over. This goes away. I'm left with a 3/4 x. Then I'm going to get negative 2 plus 5. That's going to give me a positive 3. Okay. Now I have a 4 on the bottom. I'm going to multiply by this 4 to get rid of it. So I'm going to multiply by 4 to both sides. So that's going to eliminate that. I'm left with a 3x greater than or equal to 12. And then lastly, I'm going to divide by 3. So I get x is greater than or equal to 4. So that is my first solution. Remember, this is still an and. Let's see what the other one is going to be. I'm going to distribute this out. I'm going to get negative 3x minus 3 is greater than or equal to 6. Okay? I'm going to add 3 to both sides. So I get negative 3x is greater than or equal to positive 9. I divide by a negative 3, and once I divide by a negative 3, remember the sign is going to change. This is going to give me a negative 3. Okay, but now it's less than. So x is less than or equal to negative 3. Okay, so now that I have both of them, now I have them in the form that I want them. So I have x is greater than or equal to 4, and I have x is less than or equal to negative 3. Okay, so let's graph them and see what they both have in common, if anything. So here is 4. 4 is included, okay? So it's included, and it's going to be everything that's greater than. Everything greater than here, okay? This one is negative 3. So negative 3 is over here, and it's included, and it's everything that's less than, okay? And notice that these have nothing in common, so in this case, it's going to be no solution. Okay? All right. So that's all there is really to it for these types of problems. If you have any questions, let me know. Otherwise, in the next video, I will do the OR case.